Sanibonani abafundi. Very nice to welcome you all to grade 12 mathematics. We're really excited about all that lies ahead. Just a few things that are going to apply generally to these lessons. Firstly, really we encourage you to try and watch the videos in an active manner. So don't just put the video on and sort of get on with something else while it plays in the background. We would be hoping that you would be filling in your SIMI workbook as you go. From time to time, we're going to ask you to pause the video in order to try some examples and then to let it play again to see how you did. Obviously, at any point, you are welcome to pause the video anyway if we feel we're moving too fast, or if you want to just review something, you can obviously just go back a little bit. One of the things about maths is that everything builds, kind of a layer at a time. And so it may well be that you have some gaps, that you've got gaps from grade 10 and 11 and maybe even from before that. We're going to help you fill those gaps as we go. So every topic and every thing we do, we're going to try and go back to the basics to really build understanding, because maths makes sense. Izibalo zicaceke injalo. Right, our first topic that we're going to do is going to be sequences and series, a really cool topic. And without any further fuss, let's dive straight in. Okay, so what is sequences? It's just a collection of numbers in some sort of order, in an order which is determined by some kind of a rule. So for example, 1, 4, 7, 10. That is a sequence of numbers. And what's actually happening here? What is happening here? Well, yeah, that's right. We're adding 3 to each term. That's called a sequence. When we add the numbers up, we get what's called a series. And we're not going to deal with series right away, but in this topic, we are going to deal with both things. We're going to deal with sequences and with series. Sequences where we're just looking at the terms, and series where we look to add up the terms. Okay, so the first type of sequence that we're going to deal with is a sequence called an arithmetic sequence, all right? And these are ones where we get from one term to the next by adding a fixed amount. Now notice it could be a negative amount that we are adding. In this case, what are we adding? We are adding 3 to get from one term to the next. In this one, the terms are actually getting smaller. We're actually adding negative 4 to get from one term to the next. And in this one, we've got kind of an algebraic expression, and if we take a careful look at it, the x's are growing by 1 each time, so we're adding an x, but the numbers, the constants, are actually decreasing by 2, so we are adding negative 2. That is what we are adding. There are two things which we call parameters which affect an arithmetic sequence. The first one is what we call the start number, and because of its importance, we actually give it its own little symbol, and the symbol for the start number is A. The second thing is called the common difference. And the common difference is the difference, and as the word says common difference, it's the difference between any two terms. All right, and it also is really important, so we call it D. And the way we find D by taking any term and subtracting the term before it. Subtracting the term before it. So for example, over here, 8 minus 5, that would be our common difference. 11 minus 8, that would be our common difference. In this case, it's 3. The common difference in this one is 6 subtract 10, or 2 subtract 6, it's negative 4. All right, and in the last one, if we subtract 2x plus 12 from 3x plus 10, we get x minus 2. The sort of way we work out the common difference, right, is to take any term and subtract the term before it. So for example, if we took term 4 and we minus term 3, or if we knew them, if we took term, say 11, we would subtract term 10, the term before it. Does it make sense? It always makes sense. Okay, if we know D, then we can get from any term to the next term. Right, so what would the next term be in this one? Well, we know that D, our common difference, is 3, so we would add 3 and we'd get 14. In this one, we know that our common difference is negative 4, So 2 plus negative 4 takes us to negative 2. And in this one, we know that our common difference is x minus 2. So we would be going to 6x plus 4. Okay. Right. A really, really important idea is that if three numbers, D, E, and F, are in arithmetic sequence, then the difference between E and D, that's our common difference, that would be exactly the same as F minus E. So that's a really important idea. It's not a formula, it's just an idea. Okay, so let's now turn over the page, Pedul Ikasi, and let's have a look at the next thing. And that is that if we know A and D, then we can write down as many terms as we like. Right? So let's do the first one together. Then we'll ask you to pause the video and try the next two yourselves. So if A is negative 5 and D is 3, let's write down the first 5 terms. So the first term is going to be negative 5. The next one, when we add 3, we're going to get negative 2. The next one, when we add 3, we're going to get 1. The next one, when we add 3, we're going to get 4. And the last one, when we add 3, we're going to get 7. Those are the first 5 terms. Now what we want you to do is we want you to pause the video and just try the next 2. Okay, let's take a look. This one will be 12, then 9, then 6, then 3, and then 0. Those are the first 5 terms. This one will be 4x plus 2 is A. The next one will be 3x plus 4. The next one will be 2x plus 6. The next one will be x plus 8. And the last one, when we add another negative x plus 2, we're just going to get 10. Okay. We use, and this is really important, we use the notation Tn to talk about the nth term of the sequence. So let's look at this sequence now. 2, 5, 8, 9, 11, 17. Is this sequence arithmetic? Well, let's look at the differences. 5 minus 2, 3. 8 minus 5, 3. Looking good. But, Kodwa, 9 minus 8 is not 3. This is not an arithmetic sequence. And the reason it's not is that there is no common difference. Remember, common means it's got to be the same every time. Right, so it's not an arithmetic sequence. However, we can still talk about the terms of this sequence. So for this sequence, what is the third term? Term 1, term 2, term 3. The third term is 8. And what we would write is T3 equals 8. That's saying term 3 is 8. Which term is equal to 5? Well, in fact, the second term, T2, is equal to 5. All right? And then, what is T5 equal to? Well, T5 is 1, 2, 3, 4, 5. T5 is actually 11. Notice the big difference, and it's a really, really important idea. So I'm just going to highlight here. Notice the big difference between that 5 there and that 5 there. That 5 there is actually a term, all right? It's the second term. This 5 over here is telling us about the position of a term, all right? So in other words, the fifth term. Okay, right. Let's continue and let's take a look. Now, what we do know is that we call A T1. That's our first term. And then a big idea also is that N is a natural number. Now, a natural number, you may or may not remember this, but a natural number, we write the N with a sort of double N like that. I haven't done that very well at all. Let me see if I can improve on that. Okay. The natural numbers are the whole numbers from 1 to 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. It's getting bigger and bigger and bigger. So natural numbers. So N is an element of this set of numbers. Starting with 1, then 2, then 3. We cannot have like the 3.5 term. Okay. The term numbers have to be whole numbers. Okay. Now, the formula for the nth term of an arithmetic sequence, this formula is going to get provided to you on your formula sheets in every test and every exam. And what it says is that the nth term is given to us by finding the first term and adding n minus 1 lots of the common difference. Okay, so now that's a formula, really important, but more important is that we understand why it is and where it comes from. So Pendruli Kasian, let's have a look. Right, let's look at a specific one first rather. So we've got a sequence 3, 7, 11, 15, right? So if we look at T1, T1 is obviously just 3. T2, how do we get to T2? Well, what we do is we take 3 and we add 4. How do we get to T3? Well, we add another 4. So now we've got 3 plus 2 lots of 4. How do we get to T4? Well, we add another 4. So we've now got 3 lots of 4. Now I want you to look at this number over here and this number over here. To find the fourth term, we add 3 lots of 4. To find the fifth term, how many lots of 4 do you think we're going to add? We're going to add 4 lots of 4. So maths is all about looking for pattern, all right? And so what we see is that this number here is actually always 1 bigger than that number. Or this number here is 1 less than that number. So if I wanted to find the 10th term, how many lots of 4 do you think I would need to add? Oh, sorry, I've written the answer in for you. How many lots of 4? Well, absolutely, 9 lots of 4. If I wanted to find the 25th term, how many lots of 4? All right, I would add 24 lots of 4. Right, now the nth term is going to be 3 plus n minus 1 lots of 4. Now if we take the brackets out of this, in other words we multiply the 4 by the n and the minus 1, and we simplify, we actually get an nth term formula here of 4n minus 1. And we can check that, all right? Because if, for example, we said, let's let n be 3, well, 4 lots of 3 would be 12. 12 minus 1 would be 11. 1, 2, 3, yeah, 11. Okay, so that's the idea. Now let's do the same again, but this time we're going to do it with the general case, all right? So the first term is a. How do we get to the next term? Well, we add d. How do we get to the next term? Well, we add another d. How do we get to the next term? Well, we add another d. All right. How many d's do you think we would need to add if we wanted the 17th term? Absolutely. We would add 16 d's. And how many d's do you think we would need to add if we wanted to get the nth term? Absolutely. We would add 1 less than n lots of d's. Right. The reason it's 1 less than n is because for the first term we don't add any d's. So it's kind of 1 out. It makes sense. It always makes sense. This formula, as we said just now, this formula gets provided to us on every formula sheet for tests and exams. It's actually got 4 kind of pieces to it, and I'm going to just underline those in different colors. That's one piece, one sort of entry in it. Then we've got A, then we've got N, and lastly the fourth variable in this formula is D. So we've got these 4 formulas. Now in mathematics, if we have an equation with some variables in, as long as there's only one variable, as long as we know all the other ones, if there's one that we don't know, then we can solve for it. And so before we go any further, we're actually going to dive back into some maths that we've done previously, and we're going to look at solving equations, just to remind ourselves how this works. Okay, I want us to think about an equation as a kind of a set of scales, all right? So those scales at the moment are balanced, all right? And that's like an equal sign. So 4 little green balls is the same as 2 red boxes, okay? Now, if we were to, let's say, add 2 balls to each side, right? Would the scale remain balanced? Of course it would, right? Okay, it would remain balanced. If we were to add 1 ball to the one side and not to the other side, it would not remain balanced, okay? It would lose its balance. We need to do the same thing to both sides. Another thing we could do is we could remove half from each side. Now on the left-hand side, there are 6 green balls. If we take blue balls. If we take half of them away, we'll be left with 3. And if we take half away from the right-hand side, now in other words, we would need to take one ball away and 1 box away. 1 blue ball away and 1 red box away. Would it remain balanced? Of course it would remain balanced. All right, an equation is just like a set of scales. As long as we treat both sides the same, it will remain in balance. Right, now we're going to look at another idea around solving equations, and that's just a simple metaphor of getting dressed. Getting dressed and getting undressed. Okay, so when we get dressed, and we're just going to use 3 pieces of clothing here, all right? A pair of underpants, then your amabuluke, then your longs, and then your shoes. Okay, when we get undressed, what comes off first? Absolutely. When we get undressed, the shoes have to come off first, then the longs, and only then the underpants. Okay, so let's now look at an equation. Here we've got an equation, 3x minus 1 equals 20. If we look at what's happening here, x is all dressed up, all right? What's happening to x, and in what order is it happening? The first thing that's happening to x is it's being multiplied by 3. That gives us 3x. Then we are subtracting 1, and that gives us 3x minus 1, and that we know the answer to that is 20. Now we want to undress x. We want to go backwards, all right? What's the undoing of subtracting 1? It's adding 1, all right? That gives us 21. What's the undoing? And later in this term, we're going to do a topic called inverses, and the actual correct word rather than undoing. The undoing of timesing by 3 is dividing by 3. The inverse of timesing by 3 is dividing by 3. And if we divide 21 by 3, we get 7. And 7 is the answer to that equation. Now, we're not going to expect you to set your work out like that, but we hope that that little visual process of dressing and undressing, and when we undress in the reverse order. We hope that will be useful. Now let's look at how we'll set out the solving of that equation. In your mind, I want you to think of a set of scales. They're balanced, right? We're trying to get x on its own. We don't really want this negative 1 over here. Can we, what can we do? We can add 1. Now, which side should we add 1 to? Absolutely. To keep the scales balanced, we're going to add 1 to both sides. We get 3x equals 21. Now, x is being multiplied by 3. What's the inverse or the undo of multiplying by 3? Divide by 3. Divide by 3 on which side? 100% on both sides. There's our answer. All right, that was just quick reminder about solving equations, because we're going to need to solve some equations right now. Now we're going to look at, we're going to go back here, and we're going to look at using our formula, all right, determine the 17th term of this sequence. All right, now remember the formula, there it is, Tn equals a plus n minus 1d, so let's write it down, Tn equals a plus n minus 1 lots of d. Now, what they're asking us for here is they're asking us for T17. So we must know all the other variables. There's 3 other variables. There's A, there's N, so let's just use a different color here. There's N, and there's D. All right, let's see if we can fill all of those in. All right, T17, well, A is 7. N is 17, so this is going to be 16, and D is 3. We're multiplying by 3. Right, now 16 times 3 is 48, and 48 plus 7 is 55. Right, now, another thing, mental arithmetic, being able to do that without a calculator. the more you use your brain, the better it will get. If you use a calculator, you'll become lazy. If I say to you, Yinile, what is this? Okay, and I'm not sure if you can see properly, but it's a cell phone. Okay? You don't have to stop and think about that. You know it's a cell phone. You need to know that 9 times 7 is 63, 8 times 9 is 72. You need to know those things. It will help you tremendously. You can get better with practice. Right, what I do want to show you now, all right, just before we finish this lesson, I want to show you that, in fact, there's a tool called Microsoft Excel, all right, and here it is, okay, and Microsoft Excel can actually repeat patterns for us. Okay, I'm just going to make the font a little bit bigger here so we can see. So, for example, if we put in Monday, all right, and we go to the bottom right corner and we drag down, it will complete the pattern. If we put in January, all right, and we go to the bottom right corner, it will continue. All right. Now, the amazing thing about Microsoft Excel is that if we put in the first 2 terms of an arithmetic sequence, it will continue it for us. So let's just remind ourselves what our sequence was. Over here. Okay. It was 7, 10, 13. Right, let's go back here. 7, 10. Okay, so what I'm going to do now is I'm going to select both of those and I'm going to drag down. All right, I'm going to drag kind of a whole long way down. And there it is. It's kind of completed the sequence for us. But let's go down, and I'm hoping you can see the numbers on the side. Let's go down and look at the 17th term. Ah, there it is. The 17th term is in this row over here, and it is indeed 55. Okay, right. That just confirms what the calculation that we've just done. Okay, right. Let's see if we can get out of here and back to here. Right, now let's do, in fact, we're going to stop there. We're going to ask you to see if you can do this question and maybe a couple more for homework, and then we will be back tomorrow and we'll go over them. Right, thank you. Have a great day.